Okay. So today we just going to go through that Netflix OSS. What is the Netflix has been contributed to the Spring Cloud. So Netflix, as we know, is has like a open source software framework that they later on uh, open source after they have developed those technology into the Netflix organization. So what are the different components that Netflix OSS do support? So Netflix OSS is mostly when you see there are lots of different stuffs that are involved into Netflix OSS, but we will be only focusing on that the OSS part where this is related to the common runtime services and libraries. So under common runtime services, what we have like different tools, different frameworks, and those are basically Eureka. Then they have like a well-known service which is basically used to record the service discovery. So it's like a server which can have multiple microservices. Spring Boot microservices can register with them with a name. It is not your DNS name or anything. It's a normal service name that you can register with. And if that particular microservice, say two microservices are registered, service A and service B, and if the services need to be interact with each other, then they need to be having communicate via the Eureka server via the proxy. Where the proxy is basically you pass the service name with which is registered at the startup, and then you can communicate over that. Next, so this will help us to perform the same operation that we normally find with the DNS, a domain name service in AWS, a normal domain name service that we find. And it also act as a load balancer service. And when we doing the inter-process communication or service communication, we can also use a client-side load balancer that is known as ribbon. Okay. So from the client side, if you have like a list of servers, so it can use a round robin method to connect to those particular services via the Eureka service, and it can communicate. Now, all this inter-service communication is not always stable, right? They can be fault. When there may be fault or there may be latency issue or encounter at the runtime, then they have another thing that is known as hysterics. So hysterics in another form of fault tolerance, which are being used to you know implement the circuit breaker pattern, which is basically architecture pattern where you are making a call to another service A to B, and in between if there is any fault, right, that occurs, then the circuit they can be open, and if there other services are able to find that particular service is responding, then that will be closed and you can make a call to that. In case you are not getting the responses back, you can having like a fallback service, a fallback method, which you can return the response in case you are not getting that. So these are basically available as a library. So they are basically also can be used in your code base. Okay. So we're going to be looking into these two services for now. So what happened is Spring Cloud for Netflix. Initially, when it started, it provided the support for Spring Cloud for Historics, Spring Cloud for Ribbon, Eureka, Zool. That is the gateway service, right? You can control which services you can access and which services you cannot. Okay, but gradually over the period of time, what happened is these services are not being out of maintenance, and they are being later on replaced by the with the corresponding Spring Cloud native projects. So initially they have like Netflix Eureka client, Netflix Eureka server. Then also they have like a remote configuration, that is RKS, and Netflix Ribbon, that is the client-side load balancing Zool. And then you have Netflix Histories and Dashboard. And also for performance monitoring, they have Turbine. So let us see what it takes in the code base side to using those services. And let us see some sample code base. So in the sample code base, what we have is we have a sample Gradle application, a Spring Boot application. So in the Spring Boot application, what we need to enable the, so we obviously required is a Eureka server. So what happened in a Eureka server? The server is registered itself. Okay. So you can add, enable Eureka server, and also you can say that I wanted to enable the discovery client. So those two features are being enabled, and rest is just a simple Spring Boot application. Okay. Now, when this service is going to be running, it's going to have this configuration. So your Spring application name, you have chosen Eureka. You have basic authentication, you have disable. Then you have use a custom property name, that is the app info, server port, etc. So by default, you are not registering this client side because this is a server side, so there is no need for a client side. So you are not registering the Eureka itself to its, or neither you are going to be fetching the service registry that Eureka consists. So what is the help of, what is the importance of service registry or server side service discovery is that you don't depend on that. It's a basically alternative on depending on the load balancer or any native cloud provider implementation, rather than you can implement all these services. And Eureka server are basically the, in that case becomes a your critical point of failure. So in case of your critical point of failure, what will need to be happening is that you need to create each region. So basically in AWS you have different regions, right? Like for example, in India there is a new region has come up recently in Hyderabad, right? So if your services are running in the Hyderabad region, or they are also running in the Mumbai region, right? So each region going to have its own Eureka servers. Okay. So even if one particular region goes down, other region can keep serving your API's responses. And then on the server side, it basically says that how long it would be wait in the millisecond when the sync is empty, that is 0. So that's all the configuration you need to create, and then you need to run this particular service. And you will be also seeing the dashboard for now. Now that means the Eureka service, right? Now here we have two servers, two services. One is the membership service, which is another Spring Boot application. Okay. Here only has a single file which is having everything. So this membership service is basically going to be calling to the your recommendation service. Okay. And this recommendation service will return some responses back. Okay. So first of all, these services need to be registered itself to the Netflix itself, Netflix Eureka service. So under Eureka, it says that what is the application group name. So it's a unique group name that has been given. So that is the sample user or something. And then client server URL default zone. That is actually path of that particular Eureka service that you are running separately. So with that particular path and the name, it has been registered itself. And here you have just same thing, it's a membership service, etc. And you have like a Atlas dashboard. So that's a different other thing that you are connecting to that. And dashboard HTML is nothing but it's a just a React application, which is basically just making some calls to the backend API that is there to getting the graph of stuff of that. So then now this membership service is there, and there is also a recommendation service is there. So similar to your membership service, the recommendation service will be registered. When it's going to be registered, it's going to be registered with the Eureka client. Okay. Here we're going to coming back to the Fein clients and the circuit breaker with history configuration, etc. there that we can look into. So out here you have the recommendation service. So recommendation service is also registering itself. Okay, here it is going under the application group name sample. And what is the service name under the application group names will be recommendation service 1 and 2. So multiple instances, obviously a service is going to have like a multiple instances. So that particular multiple instances will be there. And you can also say what is the host name. That is by default some kind of a host name has been also registered. So you get to know which is the service, which is the host name, and also you put that particular Eureka service that is there. Then you have chosen a different port number, separating that what you have from the your sampling. So you can run the both of the service together out here. So now okay. So recommended service has so recommendation service is going to be making a call to the membership service. Okay. So when you're going to make a call to the membership service, how the client can be used, we'll come into that. Now here you have recommendation controller, which is just API recommendation. And then you have membership repository. Then you have different kind of recommendations of movies that has been mentioned, which are static set of movies that are there. Then you have finding the recommendation for the user against the user ID. So out here, so here both of the services has each other details, right? So how this service is going to have the detail of that particular service. So let's see. So here is the another thing is that when you wanted to communicate to another service, you mostly use what? We mostly use either a web client or alternatively we use a REST template. So REST template will be deprecated in near future. So mostly it is advisable to use the web client out here. So out here you have a declarative client where we don't have to write many things out here. Now here in the Fing client, we have given the name as a membership. So if you go back to the membership service, the application name is registered with the membership. There's no other configuration like what is the Eureka server URL, etc. We don't need to mention that into the code. Okay. Only thing we need to mention that if we need to call another third-party service, we're going to be calling the particular service name. So what is the recommendation service is using? It using declarative client. Okay, so you don't have to code for that. And what you are actually mentioning in the Fing client. So here you have enable the Fing client, which is basically going to be your declarative service. And in the Fing client, what you mention is, okay, I wanted to make a call to that particular service membership. Now, what is membership, where it is located, how it's going to find out? Because it has already has enabled the Eureka client out here, right? So when it's enabled the Eureka client, then obviously the particular instance has been registered itself to the same Eureka client URL. And based on the Eureka client URL, what you're going to do, it's going to be resolving the membership. Now, in the membership service, there is which endpoint you need to call. So in the membership service, we have an endpoint. As I hope here it is mentioned. Here you have the API member slash user. And from the member store, it's just returning the user, depending on the username that is there. This is just a sample example. And that is the your request mapping. By default, it is get, not specific mention. So it is by default is get. So coming back to your recommendation service, what is saying that I'm going to be accessing API member user and I'm going to be using get and my path variable is user. So obviously by default, it's going to be resolving that particular service from the service registry of Eureka, and from the service registry of the Eureka, it's going to be able to extract the data and it's going to be able to fetch the user, whatever the user name that is there, right? So this method it will be calling. So that Fing client is simplified our API to API calls. Here, the Fing client itself is a component. We can import that into membership repository. Now, after it goes to the membership repository, it's going to be returning the recommendation for that particular user. Now, the user may or may not be found, right? If you use a different user ID, then it may not be there. Okay. So now, out here, let us look into the second component, that is history and history dashboard. So this is history dashboard. There is dashboard that has been enabled, which gives you the time of operation, failures, and other detail. So that another Spring Boot application. Now out here, if we look into the build.gradle file, what are the dependency we have taken out here? We have only used the Netflix Cloud Activator and the Spring Cloud Starter Netflix dashboard. So these things are being included. Now, apart from this, there is nothing more need to be done. Now let's look into that. So this is simple basic things that which path is going to be executing, what port it going to be executing. That's fine. Now, what is the history provide? History stores the detail of how the APIs are going through from this, right? And if there is some failure, then you need to fall back to certain alternative, right? So if the user detail you are not able to find, so in case of a Netflix, they cannot recommend the movie as per the user preference. It may happen the member service may or may not get filled, right? So in that case, what happen is that you have to then use a fallback method, right? And you need to also configure the strict circuit breaker configuration. So here you have like history command. It's going to be ignoring the exception user not found, right? Certain exception is not going to be fallback to that particular method, that is recommendation fallback. And and then it has like history property, like what is the threading logic, because it runs within a thread. What is the timeout in millisecond? That is 5 seconds. And what is the thread isolation? Execution isolation strategy is using semaphore. Okay. So it finding that particular user detail, right? So it's going to go and then it's going to be calling membership service find user not found. Find user, right? So find user is coming from the repository. If the member is not there, then it's going to throw the exception. But okay, but it's going to be ignoring that particular exception. And then if the member age is 17, that it's going to be less than 17, then it's going to be recommending some kid movies, or it's going to recommend some um, adult movies, right? And for the fallback method is just returning the value for the family recommendation section. That's all you have to do for the stick configuration to be include into your code base. Okay. Let's look into the other things also. We have like a event listeners, right? So what is the event listener does? It basically listen to any kind of event that may occur within the Spring lifecycle. So here you have Eureka status change. If the Eureka status get changed, so you're going to check whether the instance is down. Else, it's going to be showing that instance is out of service. Okay, so that's a basic thing. So that's is basically both of the services when it's starting, they're registering itself using Eureka client. When they wanted to communicate, they're using Fing. They are not using declarative or code base using either REST template or web client. Okay, they enabling the Fing kind and they enable the Fing kind using the same service name or application name that is registered within the Eureka server. And then they are also using the historics fallback method, ignoring exceptions, and the thread management that is there. Done. Uh, Let us see in the strict dashboard, right? There is nothing more. Just need to enable the strict dashboard. So it will show the dashboard as well as enable the history server.
Okay. Now here they are showing some random delay using just a delay function. Now okay. So the next thing is about how many times the message are invoked, right? Or some kind of a matrix if we need to be calculating. So for Netflix OSS, they basically use turbine master, which is basically act as a monitoring server. So out here in the turbine, let's look into the build.gradle. So you have imported this and you have used Spring Cloud turbine. I mean actuator and web. Okay. So here you have to use any kind of matrix that you wanted to collect from the application. You can use the enable turbine method. So what is the turbine method does? It's start the turbine server, which captures the turbine, the matrix detail. So here turbine is also be registering with itself with the Eureka client that has been running. Okay, and then it going to be sampling and aggregation, sample based aggregation on the application recommendation. So whatever matrix that recommendation service find those across it going to be aggregating on that. Okay. Let's now look into the sample recommendation. How it actually sending the okay. It is mostly out here in the member service, which is basically we called. So here you have just using another configuration. Okay. So here you are integration component scan. You are just using the base control gateway service, which is coming from network sample membership. Okay. So this is like a messaging gateway that is there, and it has like a send method that is there. Default request channel is a control for now. Now out here, what is doing? So here some event listeners are there. One is the when the Eureka server gets startup. So Eureka status change event on that class, and the condition is status is up on that particular class. When the event status is up, then it's showing the starting the adapter control channel sent the application channel adapter has started. So using control channel, it's sending the message there, and when there is an event change, that is showing that it has been stopped. Now these two event listener is there, and then you have the control bus gateway, the control channel that is there. Now you are initializing the matrix factory, default matrix factory. Now how the default matrix factory been used? Okay. So now here you are getting integer message source. So it will return an integer value. The method invocation message source is there, which is taking an atomic integer. Get and increment method is called on that. So that is one source that they define. So message control channel, they are directly getting that. Notification flow is right. Have control and then configure Astro startup to, then ID is control bus. Direct channel, they have like input channel, and then they are using polling as a fixed rate of 100 millisecond. The channel is input channel, then filter P, if the P is greater than 0, then they are sending the message, etc. Okay. So just shows the example. If you need to, sending every particular second, they basically incrementing the value by 1 from atomic integer and sending the message out. You can create your own matrix and you can also send that detail out as well. And out here you have enable spectator, which is basically monitoring the particular matrix details and send it across to turbine. So here you are basically publishing to this turbine API. So turbine API, you are publishing to that, and then you are rest maximum age, that is 2000 to 1000 second. After that you are sending that. So these are the basic 4 services that you have seen, how we can configure that and how we can use in a Spring Netflix format using simple configuration. So what we learned today, if I just summarize, we learned that we can use circuit breaker with histories, how we can use your normal service, that is your service discovery and service client Eureka. Then how can we use the Fang client? And the fourth is how can you use turbine to send some matrices out from one service to that particular service. Any questions so far?
So my question is, why do we need this?
Yeah. So our question is why we need the individual services, right?
Yes.
Okay. So now, currently, what is the purpose of the load balancer? Load balancer purpose is if you have one service, uh, when in the production, you run the multiple instances of it. And load balancer uses different load balancing algorithm based on CPU load, drawdown, Rubin, etc. to evenly distribute the request against those server instances. Okay. So that way, what happen is your server instances will be properly, your resources have been utilized, and you can give a higher throughput comparing that if you wanted to do something like that, right, with a single server, right, or you are redirected to your request to only on the first instance of the multiple instances, right. So that's what the load balancer does, correct. And also the DNS name resolution happened, right? So you give a particular service name, service URL, right, against that particular your load balancer. You map that particular load balancer to forward the request a certain context path to this kind of a resource group or cluster group, which you can forward. So these are the things what is the load balancer performs. It forwards that, and if there is like a new service instance gets start up, it automatically register that, and it can then forwarded this request to that particular service. Okay. So what it does, it does 3 things. It equally distributes the load of requests among the group of server instances that are there. Then it also does is also contain a registry
For a particular service group, what are the different instances are registered with itself. Then it also do the redirection of one particular path to a particular service group, right? All the and many other operations it perform. Now, but this is always depending on the underneath system. But whatever cloud provider, each has like a different services that are there. Now, if you wanted to make your application deployment truly cloud agnostic, right? Correct. So in that case, if you don't wanted to depend on this load balancer services or the DNS resolution service, what you can do, you can replace that with the Eureka server. So what is the Eureka server does? Every time a particular service, our in case it's like a movie recommendation service or the membership service, right? Those are automatically register itself to the Eureka server. So service registry has been created and against the service registry name has been there and what are the different instances are there that will be registered to itself. Okay. So now if two services need to communicate to each other, so how they going to communicate? Are they going to be communicate with the hard-coded IP addresses or a particular specific DTS name? They can be easily communicate with the service name, with the application name, with which it is registered in the application.yml. So when it does that, then you don't have to do much. You can use that particular path instead of having like a HTTP and building the path. You can use something like a fin client, which is declarative client, where you don't have to write, you don't have to build your request object, you don't have to build your headers, your request parameter, etc. You can simply declare, okay, I'm calling this service that is registered with the service registry, and then this endpoint I want to make a call to, whether it's a gate pull and what is the path. Then I don't provide any kind of implementation. So it's just an interface, right? Then when I'm going to be use that as a client into my other application services or other clients. So I just have to auto-wire that and then call the method. Spring input Spring Cloud itself going to be provide the default implementation by passing the annotation that is there. Okay. So, so obviously this will help us to do the executions without much of knowing where the actual physical path or physical URL of it, right? We can just have the service name by which that particular service is registered with Utica, and then simply it can call. Okay, that is the two services. What is the third service? Third service is basically history transport service. So what it does? So for example, I have like multiple service in the service change API call service A, B, C, D, E, F, G, H. Now, any one time, one of the services in the service change get failed. When it get failed, what happens is the service change request so far as it process is also get failed. Correct?
Yes.
Yeah. So in that case, what history does is it implement the concept of circuit breaker. Right? When there is a failure, it open up the call that is going to that particular service. It doesn't forward the call to that particular service, which state is currently failed, because one or more other services also are maybe the same service, different instance, that particular method has been failed. So now if this service is going to call this, obviously it's going to be failed. So instead of sending the request, it do open up the circuit and it chooses or gives the user to give the developer an alternative to returning some other source, it can populate the data that the alternative data I can provide instead of failing the whole service linkage, etc. So in that case, it change, and when it get change, it can fall back to the other service, provided there is like some error occurs due to maybe 50 error, or there is some error occurs that is like your network is not available or something that break in that particular connectivity, and that particular connectivity again can be re-established provided there is a response going to that, and that particular thing is been returning start responding back again from other services, right? So in that case it will directly go there and get the responses back. And history dashboard also shows that if the particular service is currently red or it is green, what is the particular throughput, how many requests has been failed, how many requests has been currently working. So it gives the developer a dashboard to look into what is the service health of different microservices that within a system. It gives a top view of it. Okay. And then the turbine that is there, which is basically a performance monitoring tool, which is basically stores the record of different metrics or the request processing time, etc. So you enable the turbine there, you create a turbine server, and then you just create a message gateway, and through the gateway you can pass different metrics data that you need to pass along. Okay.
Sir, why we are using Netflix here?
And Netflix is like a competitive open source stack that can be utilized, right? So Netflix is also providing same kind of a services which is Spring Cloud do provide. For example, Spring Cloud do provide cloud gateway that you can alternatively use for Zool services, right? It also provides service discovery, etc. So Netflix being a popular, it has initially has a lot of traction, but over the period of time, Netflix projects are the open source projects are no longer be maintained. Okay, so they have contributed some code to the Spring Cloud. So we'll be next month we'll be going depth. What are the different Spring Cloud services are there? We got to look into each of the services independently, and then we can see how the Netflix services project current status is, what is actually it providing the maintaining. So many things like Zool is converted to Zool 2, and apart from Eureka, no other services are currently maintained by them. So that's just the introduction to how we can, in a large scale microservice architecture, how we can provide create a cloud native system with Netflix frameworks or libraries. Any other questions? Okay. If not, then we can close the session now. And next month onward, we will to look into more in detail the Spring Cloud. Thank you. Bye.
Thank you.
Okay, sir.